Hi, my name's Dan, and this video is one in a series that I'm doing on logic gates in digital electronics, and in this one we're going to be looking at the XOR gate. So in order to understand this, you probably should have some basic understanding of Boolean logic and Boolean algebra. It doesn't need to be in depth. And an understanding of the principles of logic gates, what they are and what they're about, would be helpful, and the first video in this series does exactly that. So if you want to check it out, go and check that out first. So now we're going to look at the XOR gate. What is this? Well, it's called exclusive OR. An English term for this is mutually exclusive. So this is sometimes appears in slightly more advanced Boolean logic. It is sometimes written EXOR, but for the gate it's usually written XOR. Let me illustrate this with a quick example. If you were buying an ice cream at an ice cream parlour, you probably would be asked if you want to have that in a cone or in a tub. And they're expecting you to answer one of those two, but not both. You can't actually have your ice cream in both in a cone and in a tub unless you get two separate ice creams. But also giving you an ice cream without either of those, it could be a little bit of a disaster on your fingers. So they're mutually exclusive. Let's demonstrate this, or let's show this in a truth table. So we've got two inputs, A and B. They are interchangeable in the sense that this is symmetrical, but they are discrete from each other in that one doesn't affect the other. But the output is dependent on both of them. And as this truth table shows, when you have both of your inputs are 0, your output is 0. When both of your inputs are 1, your output is 0. And only when only one of your inputs is 1 is your output 1. So 1 and only 1. So this is similar to the OR gate, if you know about that, except with the change that both inputs being 1 gives you a 0 output, or in terms of Boolean logic, if both statements were true, that would be a disallowed output. It would be false output. Okay, so let's go to Digital Works to have a look at this. This is some a piece of software that I'm using for demonstrating these gates. It's a digital simulator called Digital Works, and the symbol for an XOR gate is very similar to the symbol for an OR gate, except it's got an extra curve on the bottom there. And that's the thing that indicates that we're using an exclusive OR gate or an XOR gate. So we've got two inputs that we can manipulate. White means 0, red means 1. And as we choose either of them and turn them on, these are interactive, obviously, with this little hand thing. The output goes to 1. But if I set both the inputs to 1, then the output is 0. And if I put both the inputs at 0, then the output is also 0. The other two cases, well, one of them is 1 and one of them is 0. Demonstrate that one and that one. The output is 1. So that's it from me for now.